Good afternoon, dear judges. Today I'm going to present you a project called Limited Diffusion Aggregation coped with calcium complex formation. My supervisor of this project, Svetlana Alexandrovna Lasevich. Aims and challenges. Nowadays, the regenerative medicine copes with such disease like osteoporosis. The danger of this disease that people cannot always know that they have osteoporosis. It hasn't got any symptoms that can say that people have this disease. That's why the goal of our project was creating a model system of calcium deficient patterns and further research on the effect of these patterns on cell growth. That's why we set 3 tasks. The first is the study of growth on self-assembled structures as a model of bone formation. The second was setting the sodium EDTA in different concentrations to the system to make an approximate model of calcium deficient bones. And the last task was comparing calcium deficient structure to classic structure without adding the sodium EDTA. This method can be used to help in treatments of osteoporosis bones. In the course of work, we did a research area analysis. These states helped me to find some information about my theme, this article. This article helped me to study about the formation of Lisgang rings. This article describes physical and chemical properties of EDTA. What is Lisgang rings? Lisgang rings, it is periodic structures. In laboratory, we can call them self-assembled hydroxyapatite-based structures resulting from periodic deposition of any compounds by diffusion in gel media. Also, we can call it an approximate bone model. We can find self-assembly structures in nature, for example, in some kinds of agates, sandstones, or malachite. Osteoporosis is disease when and it forms holes in bones. Our bones become more brittle, and a person can break his bone. Osteoporosis makes our bones. Why we can call the Lisgang rings an approximate bone model? Because osteoblasts form hydroxyapatites, and that's why we can call it a bone model. The method of formation Lisgang rings. For the base, we took 1% of agar, hydrophosphate, disodium hydrophosphate, and water. In our electrolytes, we add calcium chloride, and due to diffusion, forms hydroxyapatite. On these photos, there is growth of self-assembled Lisgang rings. Now I would like to tell you about properties of EDTA. Here is a molecule of EDTA, and it has many dissociation equations. It means that it can form different complexes. Also, here is a graph that shows the formation of different forms of EDTA depending on pH. Complexation of EDTA acid with calcium. It forms ion of calcium EDTA. Here is a molecule of this ion, and logarithms of the stability constants of protonated and normal complexonated. It's important to say reactions occurring in a solution. The most important reaction is reaction of hydroxyapatite formation. Also a reaction of complex formation. It forms complex, and that's why we can get calcium deficient conditions. Also, there is a reaction if ratio calcium to phosphorus is less than 1.67. Then we can see the formation of hydroxyapatites and only calcium phosphate forms. According to our aims, we studied the influence of disodium EDTA on in outer electrolytes. On these pictures, there are solutions. These two without adding disodium EDTA as in outer electrolytes. And we can see the destruction of our structures. For these solutions, we calculated P factor, and on this slide, they are shown P factor graphs. All these graphs, all P factors are approximated to 1. So we can say that our structures are in right periodicity. Also, we did that experiments in Petri dishes. We can see the similar results, the destruction of our structures, and also as the concentration of EDTA decreases, hydroxyapatites forms so far from the place where we added calcium chloride and disodium EDTA. We can compare it to bone formation model. Our bone forms from hydroxyapatite, and osteoporosis bone has the same destruction and the same holes in the middle of it. Also, we studied the influence of disodium EDTA on inner electrolytes. We can see that as concentration decreases, our structures are not differ a lot. So I can say that disodium EDTA doesn't influence on periodicity of these structures. Conclusions. I would like to say that we have got patterns in calcium deficient conditions. The second conclusion is the effects of disodium EDTA concentration as an external electrolyte was studied, and it was found that the addition of disodium EDTA leads to destruction of our structures. Also, it was found that the introduction of disodium EDTA into the internal electrolyte leads to the formation of ordered band patterns, and it doesn't lead to a destruction of our structures. Future plans. We would like to check the reproducibility of substances with other concentrations of disodium EDTA. Also, identify the nature of the influence of other complexing agents in the formation of disordered patterns. Also, we would like to analyze the phase composition of the obtained calcium phosphate patterns. And the last future plan is to check the effect of the obtained system on the proliferation of cell cultures. Here is shown used literature. Thank you for your time.
Thank you very much. And beautiful system. I love it. Of course, the most important now to prepare it as a project which we can publish. And for this, we need all controls. And ionic strength should also affect, of course, EDTA. My assumption, EDTA affect more, because I like this part where you analyze various pK. It's very complicated chemistry. Thank you for this, especially. But to answer the questions, you should also prepare some controls. And for controls, I suggest we will take also some sodium salts, just make sure that EDTA play more role than sodium ion.
Thank you for your question, but we did controls like here is also these controls we can compare with our structures. So we did it at all.
I suggest one more serious. It will be easy. You just take the same concentration of sodium salt, like sodium chloride, sodium nitrate. Okay, all what we can find. Probably we will see some other effect, or another interesting thing can be to add also this role of if you see something with chloride, to have this like chloride, bromide, iodide, fluoride. I mean, it's a lot of space to do. But the second questions, it's all done by yourself. Okay, like previous speaker said, you haven't done yet infrared analysis, X-ray analysis, and you are planning this in future, do you? And in general, all images were obtained by you?
In the future, I plan to take this analysis by myself. All these solutions I did by myself. My mentor taught me, and now I can do it by myself. Unfortunately, we didn't do some analysis because
thank you very much. The question is about ordered patterns. Why do you think that in the presence of EDTA, the structures are more ordered than without? Just your pictures show the opposite.
I don't think that they are more ordered with adding EDTA. We did the analysis due to p-factor graphs, and p-factor showed that our structures grew in right periodicity, so we can call them periodic. I just say that with adding disodium EDTA, our structures disrupt, and here we can't even see them. Did I ask you for your question?
So it was found that adding sodium EDTA in the outer electrolyte leads to the formation of ordered patterns. Just
Yes.
I wondered why you called this ordered patterns.
Because we did analysis.
Okay, thank you.
A question about how you calculate this p-factor when you use Apples.
P-factor is this factor that shows us the periodicity of our structures. The ideal p-factor is 1. And as our structures are approximated to 1, we can call them periodic.
Sorry, the question is how you calculate p-factor.
Sorry.
How you calculate p-factor?
Calculate. I'm sorry. We calculated it due to one program called I don't remember. I'm sorry. So we just found the coordinates and we wrote these coordinates into this program, and it calculated us.
Thank you. And another question about, could you please say about how you intend to, about medical effect, how you intend to aid the osteoporosis in the future?
I'm sorry, about what effect?
Osteoporosis.
Osteoporosis. Why we can call these structures a model of osteoporosis bones? Am I right?
No, how your work is help us to aid the osteoporosis diseases.
Просто I don't really hear you. Could you please louder?
Как ваша работа может помочь при борьбе с остеопорозом?
Nowadays, we did calcium deficient models, and in future we can see how cells grow on them. So we will see how cells react on calcium deficient conditions.
Давайте поблагодарим докладчика.